Good morning, good afternoon, good evening. I am Andrew Sparrow, and this is episode 7 of the XDI Experience live show. This week, after several weeks of talking innovation and culture, we are jumping in with both feet into industry and into an industry that is one of probably the most disrupted today. Yes, we are talking ACES. That's autonomous, connected, electric, shared, subscribed, and modularized vehicles. So welcome all. Please, down below there is a comment section, so make them. If you like what you hear, please give us a thumbs up, and when you have a question, please ask. Please go right ahead. Please don't be shy, and we will do our very, very best to answer those for you right here, right now, today, and if not, pretty soon after. Okay, so don't worry, I am not about to jump on my soapbox and talk environmentalism, but did you actually see those greenhouse gases disappear during those COVID-19 times in Europe and Asia? It was amazing. You saw Italy covered in greenhouse gases, and suddenly it disappeared as the factories and the transportation turned itself off. The Nepalese were able to see the Himalayas from 250 kilometers away for the first time in 50 years. But let me put that aside for one moment. Have you seen what is going on with Tesla stock, Nikola and NIO's value over recent weeks? I think it was 400, 270, maybe 250% respectively across the board, the way they were going up. Amazing. Exciting, yes. But here's the reality. Most OEMs do not profit on selling electric vehicles at this stage. In fact, across small, medium-sized cars and even small SUVs, it is an estimated $10,000 of extra cost to produce one, and that is just not sustainable. But addressing elements of the product and the business model can put them on a better path. Today, I'm with Rick Sturgeon, a 30-year automotive veteran, more recently with Dassault Systèmes, and a man driven bringing through and optimizing the ACES sector across both big OEMs and the relative newcomers. Together, we are talking a clearing roadmap for EVs, AVs, and subscription profitability. Ready, set.
There's new energy in the automotive industry that's reinventing the business of mobility. New competitors and startups are entering from all regions. Switch on new turnkey capabilities to accelerate new frontiers of electric mobility. You can bring your best ideas to life wherever your operations are across the globe. With the same on-demand, online, highly scalable solutions used by leading global brands, you can collaborate to design and validate global innovation more quickly and enable productivity and efficiency for newly created teams. Accelerate the future of mobility for a better planet. Think big, start small, grow fast. Learn more about the processes in your solution.
Good morning, Rick. How are you? Thanks so much for being with us today. I know you've been going through a bit of a rough week with that back of yours. How you feeling?
Well, 30 years of ice hockey and being at home, going out and digging in the Michigan clay and carrying stone blocks has a price. But,
yeah,
we're in the right direction now.
You had a long list of to-dos to get through then.
Yeah.
Okay. Well, let's get you back, I guess, on your back as soon as we can and get the show on the road. Today, we are talking overall differences of approach, organizational structures, systems architects, powertrains, interiors, seating, and the future of automotive ACES. Design, manufacturing approach, and process, Rick. Let's look at the EVs, the traditional OEMs, and how we combine to reduce cycle time and strip out unnecessary costs. Give us an idea of what you are seeing as an overall EV approach these days.
Well, as you probably, all the people you mentioned earlier, is the stock prices use our 3D Experience platform.
Okay.
And I'm know about them as well as certainly the traditional. The EVs, actually, interestingly enough, they really start with really deep customer information in what they're going to build because they sort of got one shot. And it's like you would have to. They start with the battery, and then they begin building around that. And I think Tesla ended up with a unibody. Most of the rest ended up with a skateboard, but many ideas have been tried.
Okay.
And so that's the way that normally goes. And they
start with the battery, and then they kind of
yeah. But they also, because they're startups, they just try to do as much as they can themselves, limit prototyping. But the ECU is the more interesting part because it really started in California with a lot of software, let's say, focus. They really ideally would have one or maybe two ECUs and a software stack that sits inside of that. And then they build everything around the software, really, the battery and the software. And like a traditional OEM could have up to 100 ECUs. So it's just a massively different approach. And they try to do it all themselves, if possible, most of them anyway. And then they use suppliers as needed, just because of the speed and agility and so forth. And the other thing that I'm seeing is just the massive use of simulation in comparison with the traditional. I think one of the early successful Tesla models, they used actually our power flow technology to optimize the drag on the vehicle. And they produced the best drag coefficient ever produced without using a wind tunnel and on dozens of iterations of prototypes. So they were able to perform better than anybody ever has in the past, number one, and two, at a drastically reduced cost. And so, that's what we're seeing in the market, and it's very exciting.
Yeah, it's interesting you talk about that kind of very tight ship. I remember as COVID hit us in the US, that everybody was kind of shutting down the plants, whereas you've got Tesla, which were continuing because they had this very tight setup that they were vertically integrated and pretty much doing it all themselves.
Right, they're very vertically integrated, right?
Yeah, exactly. So in contrast to the EV startup, how do the traditional OEMs approach this?
Well, it's progressed a little bit, but when the OEMs typically would have a series of powertrains they have on the shelves and a series of structures. And like 90% of the engineering they know is going to work and it's been done. And then if you get a new vehicle, they would say you can do whatever you want to meet the customer requirements. And they know the customer requirements. But they say pick one of those and one of that and then do anything that you want, but minimize the cost.
Okay. So you can have any color you like as long as it's flat.
And I think one of the OEMs did that on an early EV vehicle. And I heard the cost of development was 3.5 times what they'd ever had before. Wow. So that didn't work. So now they progress, and what they've done now, so they use hundreds of suppliers and technology from suppliers, very different, very horizontally. They probably don't even know how to do most of that by now because it's been so functionalized. And so they continue that approach with the EVs. Typically, I'm sure there are exceptions. But what they've done, they said, well, how could we do this better? I mean, we're doing one-off vehicles now. The old approach isn't going to work. And they looked around to see who does that well. And they found that NASA, the Airbus, Boeing, the defense industry do one-off vehicles, really. And those had totally standardized on a concept of model-based systems engineering. And we happened to buy No Magic, the one that's sort of the standard for that, a couple years ago. And we actually see that moving pretty heavily into the OEMs right now. The idea that you have your requirements as a model and you can simulate it, and that's clear down through manufacturing, and you can just iterate things before you start building and trying them out. We don't see that in the EVs so much, although a few are starting to look at it. But that certainly is a trend that is flowing. So
Got it. So given obviously common outcomes, but pretty different approaches, how are you seeing them kind of organize themselves? How do those contrast?
Well, it's really different. And, if you think of traditional OEM, there's hundreds and hundreds of functions. But if you go to the new companies, if you just think about it naturally, they hire really good people. I mean, because they have money, they have capital. I was in a startup once. I bought into it. You go and you're going to change the world. And so, and they are. But in any case, at one of the really successful ones now. A couple of years ago, before they were, I happened to be there because they were using our platform, and there were some startup issues. And of course, since it's IT, we were put in a back room with the CIO occasionally and a bunch of people, and don't go secret out there, don't go out there. But I said, I got to go to the bathroom. So I walked out and I asked somebody, where's the guy running engineering? And, they went over there. So I went and knocked on his door, and who are you? And after we talked and we knew some common people, he'd come from one of the big OEMs, really good guy. And I said, how's it going? And, he just, his papers all over the place and, struggling. He said, this would explain it simply. He said, here's this form I used to have where if I needed a prototype, I just filled it out.
Okay.
I sent it, and about 3 months later, the prototype came. He said, there's nobody to give that form to. And so it forces everybody to extend out of their knowledge and function and really group together. And there's models for that. I mean, Henry Ford originally was in that model. He sat in the room and and told people what to do. Certainly, that's how the Obey a Room concept at Toyota, which we've all tried to copy, and even the Northrop Black, whatever it was called, is the way it's done. So that's how you innovate. I don't think there's any question. And that's what's going on in those cases. And that's, just quite different than the OEM's situation. They're still with many functions, many suppliers, et cetera.
Got it. So just driven by speed, agility, a lot more collaboration,
right?
Tighter ecosystems necessarily as well. So which could change, of course. Okay, so given the huge amounts of kind of legacy data and systems that the OEMs have, which is the potential for this economies of scale, trying to leverage that versus a semi-clean sheet of paper with an EV startup, what kind of systems are you seeing being used? What kind of architecture are you seeing being used to bring through these ACES vehicles?
Well, unfortunately, not to be too much of a commercial, but when these EVs came into place, Dassault had what they call, or early in the market, a thing called the 3D experience system, which, it's used at Tesla, NIO, Nikola, Rivian, and it just was the best thing on the market for this type of a situation. Yeah. And the reason it was the best thing in the market, the traditional PLM systems, ours included, they do a lot of things, but primarily what they do is store files. And they make those files available to everybody. Now that seems trivial, but that wasn't trivial long ago to have, somebody in China seeing a file that's current in the US. Today it's pretty easy, but that's what they do well. And check in, work on it, check it back out, but it's invisible after that. What the 3D Experience platform did is followed more of a Google model. And even when you check in a file, it pulls all the information out of it. It makes it searchable and available and integratable with other things. And that really facilitates the concept of having everybody work remotely. And even now, a few have moved it to totally cloud-based. Yeah. And for them, it also, because of the way it sells, they have the same capability of software that Boeing or Airbus has for an airplane when there's 3 of them. And that's just OEMs, the people in OEMs don't have that capability. They have little unintegrated functions. And, it really ends up eliminating all the spreadsheets pretty much. It just, and you can really, what we're seeing now is the automation of engineering with it. Yeah. Where a lot of the tasks are just automated. So it's not perfect, but it's certainly the future. Yeah. And there's a heavy use of that. Now, if I was a CIO before, not to get on, and, at big companies, and before I went back to engineering, and, as a CIO, your job is to minimize the cost, keep everything running, don't take risk. Yep. Now, the CIOs are really smart. They know what they should do, but they're not given the capital. There's not the appetite for risk. It's just do harder what you've already done. Mm-hmm. And I think at one of my past lives, we had Deloitte come in and they counted 700 and some engineering systems we were trying to keep coordinated. Well, in these startups, they have more than just our system, but they're heavily integrated in just by definition, and They work in conjunction. So it's difficult. At least it hasn't been given priority by the OEMs to make this jump, although there's 2 or 3 of the really big ones are in the early phases of making it. But I see it as a huge risk if they don't get with the program and get on the cloud. But more than get on the cloud, get into a database type of a scenario.
Yeah.
Anyway, I believe that. Okay.
Better. I understand. Okay, so that's kind of dealing with a little bit of the cycle time issues, some of the time saving, soft approaches to things, collaborative approach. Over the weekend, I drafted a little piece of content regarding cost efficiencies, and one of the big ones was around powertrain optimization. I've been seeing huge kind of differences between how startups are delivering these versus OEMs. I mean, the classic one is the Chevy Bolt versus the Tesla 3. What are you seeing that they're doing now in terms of the powertrains?
Well, I know most of them now are coming to the approach of creating a virtual model of the whole thing.
Yeah.
And we have that in our platform. We've done it for several of the OEMs, the big ones as well as the small. And they actually put the battery chemistry in the model, the battery packaging, like the cell structure, the packaging of that cell structure, how that would fit in the vehicle with different options, and a real heavy focus, interestingly. We used to think you could buy electric motors off the shelf, but this is an advantage the big companies seem to have. They're developing their own custom electric motors. And those motors keep in track how much load to put on the battery, what the, minimization. And they are using clear down to, and somewhat into manufacturing as well. But they're actually doing heavily multi-factor simulation.
Yep.
And that uses a lot of our tools, but more importantly, we can string everybody's tools together and run thousands, if not millions of cases of looking at the optimal way to put, hundreds of factors together. To give you an example, on noise, one of the big OEMs realized, one of the very advanced ones, realized that the noise of the fluid flushing inside the electric motor made too much noise in the cabin. So we developed with our PowerFlow, a next generation ability to change the flow of the fluid to minimize noise. I mean, just an example, but it's across a whole variation. And of course, that drives a lot of change in the supply base, in the design and everything else. But those vehicles are starting to, at least in the early stages of coming to market. And, an interesting one, I think you and I discussed it with one of your questions earlier. We had, I think I can probably mention, a canoe in our vehicle at CES. We had the vehicle there. We had them there because they were the first to ever develop a whole vehicle on the cloud. It's just I don't think it had been done before.
Yeah.
And of course, everybody came to look at it. My buddies, some of them not my buddies, the traditional OEMs came and looked at it and said, they did this all wrong. So what do you mean? Well, they got this in the wrong place. And because there's a hierarchy of how you should build a vehicle, the powertrain. And then I went to the canoe guy, the chief engineer. I said, you got it all wrong. He said, no, they just don't understand. And he was from an OEM too. He said, what do you mean? He said, well, we decided to the customer wants us to optimize the interior space of the vehicle. And so we moved a bunch of stuff around, not to make the ideal powertrain, but to make the ideal vehicle where the powertrain works to the specifications. And I think they were able to achieve, one class more space, like in a large sedan, the same space as you would get in a SUV. And then I told a bunch of the guys from the OEMs that they'd done that, and they all sent people back with cameras and got real interested. So it's a lot of innovation.
Agreed. So let's talk in space. Let's just cover off another bit of cost efficiency. I wanted to jump into the interiors. The buttons, the displays, the new space, because those batteries are in the base and there's not an ICE up front. So there's a new environment there, seating, etc. What are you seeing going on for cost efficiencies, different approaches for the interiors?
Well, when you and I talked earlier, you said, how are they reducing cost with the interiors? And actually, it's the opposite right now because of where they are in their cycle.
The startups,
they're actually, well, outside of getting you to the showroom because it's a really cool looking electric vehicle, it's the interiors that typically sells the vehicle.
Yep.
And so because they need to sell their vehicles, they're really trying to have distinctive experiences in the interiors. I think in Tesla's case, for example, they went with pedestal back seats and white ones. Well, pedestal back seats are heavier. probably be more expensive, and weight is a big warranty issue. That said, they're selling a lot of Teslas, so I'm not saying they got it wrong.
No.
But there's this whole focus on, and I think we talked a bit about the, all of the user, heavy move to touch, because if you have this central computer,
yep,
it's constantly changing, touch type of capabilities and heads up displays and things, which is really modern electronics. But that's what I'm seeing in the interiors. And I think if you go to an auto show, there's many, many attempts.
Yeah. I mean, I think what I've seen is that you take an old ICE and you've got 30 dials and buttons versus the EVs where you're talking about, 4, 5 maybe? I mean, that's got to be a significant cost reduction.
Oh, yeah.
So, nudge into the future. What about the new wave autonomous vehicles, shared, subscribed vehicles, maybe even modularized? What are you seeing there?
Well, in the autonomous, it's quite different because the steering wheel and the pedals become, I think that in many cases they're there, but not very important.
Yeah.
And so, the scenario of relax, entertain, and control. Mm-hmm. In other words, for the various uses you might see in your vehicle, try to optimize that. But, you still got to pass a crash test typically. Yep. So, if you're sitting around the round table, you all got to survive. And so I think that's just wide open space right now, even to the point of where some of the controls are being buried into the interiors, which is pretty cool, almost like the front pad on your Mac. Yeah. And so there's a lot of activity there. Now in the shared, that's different because there's really two customers. One customer being, who's going to be in the vehicle, but the other, the provider. And I think in one space, you could say the right thing right now for a shared would be the hard seat of a New York taxi covered by clear plastic. And every time somebody's in there, you hose it out with disinfectant. I'd probably get in that taxi. But longer term. Okay,
not in the summer, but yeah, keep going.
Like in an airplane, every couple of years, they replace the interiors. And it's very difficult to do in a modern, very expensive in the way they design modern vehicles. Yep. So for the interiors of the shared, they're trying to address that. And some of them even to the point where they would change it between rentals, although I don't know they've ever really accomplished that. But, we're really focused on how can that work. So
Got it. Okay, so let's get out the crystal ball. Let's look to the future. A lot of people in the automotive sector, and I'm sure a lot on the periphery as well. What is coming next for automotive, ACES?
Well, if you look at the situation, you have the startups that are vertically integrated, one ECU, really fast to the market. And you take the traditionals that are attempting to carry forward their model into this space with leveraging their suppliers because they're very horizontally integrated. Now, we didn't cover the advantages in that. There are huge advantages in that. I mean, every part is fully certified, it's specified, it's can run high volume, it works. And then you have all the IP of all the suppliers feeding in. And then you also, when you have variations, which most of the startups haven't handled, you can manage those variations across all models. And in the end, competitively bid it and keep the price down. Vertical integration in the end, and we proved it 30 years ago, in the end, it's very costly. It's not cost effective. And you hit some of that earlier. And so, but that said, one of the guys one of the OEMs said, was a chief engineer on one of the vehicles of an OEM some years ago. He said, 3 years before production, I told him I wanted a small software change made. And they told me that was impossible. And and he said it might have had to cross 10 ECUs. So clearly the concept of one ECU needs to move forward. And I asked a lot of people to answer that question, and they said, that's a good question. Okay, so a good question. Then one guy looked at me, and he had just retired as one of the main engineering people at one of the largest OEMs, and he knows me well. And he said, Rick, the answer is right in front of you. Why can't you see? I said, well, I don't know. And he said, he knew that I write software as a hobby. Okay. And he said, how many things have you put out in the iStore for the iPhone? I said, well, quite a few. He said, did they steal your IP? And then, no, they can't steal my IP. And he said, well, most likely using model-based systems engineering for development, and then leveraging an ECU that isn't all custom like most of the ones are today, but is more like an iPhone operating system, where the sensors can become really mechanical devices, but then the suppliers can still put their IP and innovation in there, and pulling that all together is probably the way it's going to go. Well, then later on I found, and I'm not mentioning any names now, that one of the OEMs already is moving in that direction. So I think that's pretty exciting. And but maybe it's not right. We'll see what your guests think.
Yeah, let's see. Okay, thank you.
And the last thing I didn't mention, and this is probably for those of you that are more business oriented, this is my opinion, but I'm pretty sure it's right. Using the integrated system and the vertical approach, I see the new companies probably producing a vehicle for a third of the cost in half the time. That's my own sense. So there's money behind this, and it's worth going to the future.
Yeah, that is significant, and that strips out that 10K plus overrun on costs. So very good. Okay, into Q&As. I'm taking a look around. Before the show, we got a lot of people who kind of wrote in and say, wish I could be with you, but couldn't quite make it. And so they put in a lot of questions. I think we've got 15, 16 questions lined up. So we won't go through all those. Let's just take 10 minutes now to look at the questions that have come in. I'm going to pull up firstly one from Gareth Zimmerman. He asked, what tech information can be platformed, engineered / shared between companies to accelerate stage implementation to allow standard compliance across continents?
So certainly we're seeing, if the question is based on a lot of people are co-developing, but if you're talking about, I'm actually on the SAE committee that's supposed to come up with the standards on how you will validate an autonomous vehicle. Yep. And maybe that's the best way to answer this. And we actually looked at what everybody's doing, and we're all connecting through the people from Intel and all the people you would think are in that group.
Yep.
And we're developing the standards to do it. And so, but the thing when you develop standards, you can't really say, here's how you have to do it. And, there's a lot of work to not be too tell people what to do. But I think one of the other questions I might even answer now, but you put things in there like when everything goes wrong, you have to have the ability to take the vehicle to a safe state. Yep. Whatever that means. And so I think all the standards bodies are building with questions and compliances in a pretty international way. And the OEMs are generally on those committees and all thinking about how they're going to get an advantage to do it. So I think it'll be a mix of standards that are probably pretty well aligned. And then also each manufacturer will make their little jump. And anyway.
Very good. He also asked, how can a common universal strategy and an implementation roll out nationally and internationally be achieved specifically for level 4 autonomy? Do we start with certain motorways or inner city zones?
Well, I have an opinion on that. I was asked to speak at the Meeting of the Minds, which about sort of this a year ago in Ann Arbor, and I thought about it a bit. And when I was doing it, I found that, and you always look for value. I found there's an old MIT study from 10 years ago, and they tried to figure out how, if you have autonomous vehicles, or how long does it take you to get into a city through traffic lights? And it takes you about 90 seconds per traffic light, in a lot of the urban areas where probably these make the most sense. Yep. And but if you go all autonomous, like not even one non-autonomous vehicle that isn't in the game, it all falls apart, because what you do is you turn into swarms, all the vehicles, and there are no red lights. They just swarm through, and then each red light becomes 3 seconds. So I've asked people in the past, if you wanted to do that, and I think some of the cities in Europe have been considering it, and they were all autonomous and they were flowing there, you could have a bunch of effects. You could certainly eliminate all the real estate in garages, because now most people will only like to go an hour and a half most on a commute. You could massively reduce that commute by I don't know, 90%, 70, 80%. And then you can actually extend out further where they can live out into, and if you think of our West Coast and our East Coast, those would be huge advantages. And I think the other part of the question, really, at least its current capabilities, it needs to, it's not quite ready to operate, wide open out on the highway. It could, but I think that'll be a bit for liability. But you could have roadways that were just like lanes that just the autonomous vehicles could flow in. So my own guess is there'll be these lanes that go out where the developers are just cleaning out up in these country-like estates where you live, and you take the lane in and you flow right into the city. It's different, especially with what's happened with disease. If it doesn't go away, you'd be in a car, you'd be safer than the subway. Anyway, that's, we'll see in 30 years if I was right.
There's a lot of conversation we touched on another show where we were talking, is autonomous driving eco-sensitive? Somebody said, well, where do the vehicles go when you're at work? Assuming we're working in an office and not at home, et cetera, et cetera. So there's a lot of conversations to be had. Let's jump on to the next one. David Sherratt asked, let's see what we got. Straight down to autonomous vehicles. How will autonomous vehicles integrate with current vehicles?
Well, that's happening. And I think the hype for everything autonomous was really hot a year ago. And the realities are starting to set in, although in some places it's continuing.
Yeah.
What I've noticed is the technologies are going into the new vehicles, but in a different mode. We took Ralph Nader a few years ago into the Automotive Hall of Fame, and after his sort of the way he speaks, he pointed out that by getting the National Highway Safety Institute in place, he had saved 2 million lives in his career.
Wow.
But there's still about 40,000 people in the U.S. Killed, 10 times that injured in auto accidents that are 90-some% driver error.
Yeah.
Well, I believe that this technology, and when I was first saying that, it was, heresy because it wasn't saying all autonomous. But I think in my time frame, and maybe most of yours, the goal on getting rid of those 40,000 deaths of the occasional problem with hardware, but almost never, should be a goal. And it's very, very achievable, probably with the technologies that we've already developed. And, using that as a basis to actually get them into the vehicles is probably something that's, could be good for any of us and our families. Yeah.
Agreed. Okay, let's change it out a little bit. One from a gentleman called Stephen Hewitt is asking about composites. How the bigger names, so the large OEMs, are adopting high volume composite manufacturing to reduce cost and cycle times. What are you seeing?
Well, you keep hitting on my things. So I'm an electrical and a chemical engineer that's always managed mechanical engineers. Mm-hmm. But electricals are finally winning, by the way.
Yeah.
But it's been a long road. Well, I was asked to speak in place of our composites person. We have a platform, we call it something. Anyway, in aerospace, we've developed the ability to really engineer composites and then print them in quite a leading position. Our SolidWorks tool is sort of the core of that, but it's much more than that. It has integrated simulation, et cetera. Because with a composite, the way you design it isn't the way you have to make it, because it shrinks and moves. And anyway, so I spoke at this big car conference on just that subject. Mm-hmm. And I again had to dig in and do research and try to figure out, take what we had as a tool set, which is fabulous. But in automotive today, there are very few parts that have been used in production. I think Ferrari had one. He was there and he's really proud of it. But where they are being used is in service. So I think one of the big OEMs, rather than stocking every switch that you can ever imagine, they just additive manufacture it. And during this talk, it's a big conference. I talked to many of the additive manufacturings, and certainly they're trying to speed it up. But and I don't know where the volume level will be. At some volume, certainly in prototyping, the fact that you can certainly in DV you can make and maybe especially around plastics, you can make parts without soft tools. Huge cost savings. Ideally, you would simulate, but if you can't, that's the next step to do it. But in the end, the way additives you make them today, they're probably never going to really, at a certain volume level, compete against a tool. And I know that's sort of heresy, but I think one of the big OEMs, although we found very few in production, they had 500,000 additive parts in manufacturing for covers, for different things. And in the past, I was a manufacturing engineer early in my career. You would have to go to the tool shop. They would give you some unbelievable quote made out of stainless steel in 3 months. Now you can literally go and, if you're good enough, make the little model. It doesn't have to be perfect. Hit the button and, 15, 20 minutes later, you have your part. That's a huge, huge advantage.
Got it. Good. I think we are time up, Rick. Thank you for all of that. That's great. Thank you, everybody, for comments and questions. I know we haven't necessarily answered all of them, but we're going to endeavor to do that over the next couple of days and get those back to you. Rick, go get that back fixed. Rest up. Let's do this again. There's so much more we need to talk about in the ACES automotive sector. There is so much going on. Big thanks. Thanks a lot.
Thank you.
All righty, we are talking next week. We stay in the ACES space next week, and we are going back to where it all started out, according to Rick, and that is the CX, the consumer experience, the customer experience, and the user experience. Join us to talk to a friend of mine who, with so many diverse industry backgrounds, it's really interesting. He's been across telcos and a few other things. He has now embedded himself in the automotive ACES customer experience space. We are ending up focusing in that area. We're talking purchasing experiences, using experiences, and servicing experiences in the new age of automotive. Can't wait. You all have a great rest of the week, and we will see you next Thursday, 9 a.m.